Welcome back, everyone. Shall we proceed?
Yes, sir.
Yes.
Okay, so for yesterday's recordings, we will be getting the links in a short while. Will be posted in the chat box only, so don't worry. Okay. Fine. So give me a minute. Just going back to the last state of the whiteboard, where we discussed about few of these things. Okay, so here, first of all, we are going to talk about the execution cycle of a .NET application. And for that,
Uh,
yes,
yeah, I actually have a question.
yes,
Since .NET is by default available in all the Windows distributions, and also it supports many programming languages like C# and VB, why
yes.
don't the developers of .NET extend its capability to support other languages like Python and C and all of that?
Say basically, these are the proprietary languages created by some different organizations, first of all, or the open source community work. So
Okay.
Microsoft officially cannot get into that kind of development, but yes, they do provide the support already. If you talk about C language, it's not something which actually can be considered as fourth generation language, which is a
Yes.
minimum requirement for .NET, right?
Yes.
Uh, for that, we already have managed C++ where C features can be anyways used, correct?
Yes.
Because C++ does support all the C features,
Yes.
correct? So
Yes.
we have support for C. Then whatever popular language name you take, most
Mm.
of the languages are actually supported, though not officially, but unofficially we have them supported here. So if you talk about Python, Python is supported on .NET by the name Iron Python. There is an
Okay.
adapter which has been created by the name Iron Python, with the help of which you can actually do the Python based development for .NET.
Okay.
Likewise, we have Iron Ruby for Ruby, and then we have COBOL.NET, Fortran.NET, the old days languages.
Mm.
Why that has been provided is because if the older systems which are not yet changed needs to develop further, and we have decided to develop the new features in the new age frameworks like .NET. So probably going forward, the program will be in C Sharp or VB or something. But what will happen to the old work? It cannot be migrated overnight, right?
Yes.
So what they do is they say that okay, keep that work as it is. And with the help of this COBOL.NET, Fortran.NET, you can create adapters, which then can be integrated with the new .NET based development, uh, with the help of which ultimately you will be communicating with the old stuff. And these adapters being written in Fortran or COBOL only, they are aware of the Fortran or COBOL environments, and at the same time their output is going to be the .NET output only. So you will be getting the CIL and all, right? So they can integrate both worlds together. You have Pascal.NET as well, and so on. So around 80 plus languages are there that are supported.
Okay, okay, got it.
Right, and when I say 80 plus, I believe that must be covering most of the popular languages,
Yes,
right? Because how many languages are there? If we sit and count, maybe huge number will come up, but how
yes.
many of them are actually used or actually they are popular?
Okay,
So most of the popular languages I said are supported.
okay, okay, got it.
Okay, so with that itself, with that discussion itself, I would say, suppose I have some source code written in C Sharp. There is some source code written in VB.NET. That's a remodeled version of VB, which has been designed to work with .NET, right? Syntactically, it is the same with additional features of .NET coming in. Then we have, let's say, J Sharp, which is the Java adopted in the .NET arena, though not officially supported by Microsoft, but by open source community, the compiler has been created for Java in such a way that the output is not bytecode, but the output is MSIL, so that it can be integrated and treated as a .NET language. Then we have managed C++, right? Source code can be written using any of these languages. And I said 80 plus languages are there. So dot 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 represents all the other languages. Do you get it? Yes.
Yes.
Any idea why I have written these languages on the top? Just to represent that the source code can be written using any of these languages. Do you get it?
Yeah.
Okay, so can I say here this is going to be compiled by the C Sharp compiler named as csc.exe. VB.NET has got a VB compiler called as vb3.exe. J Sharp compiler doesn't come by default with .NET framework. You have to download and install it explicitly, and that is named as JSC, uh, J Sharp compiler .exe. And from manage C++, let me confirm because recently the name of the compiler has changed. I mean the exe name has changed. So just give me a second. Yeah, so it is named as cl.exe. And for other languages, their source code compilers would be there. Correct? What is the output of these? We discussed that in the previous session. Be it any programming language, the output is always going to be something which is represented as another programming language named as MSIL, old name, with new name being CIL. So most important part is this IL. IL is intermediate language. This is not machine code or bytecode. This is programming language statements or set of programming language statements only. It is in itself a language near to assembly language. And because of that, this actually, whatever the exe or DLL you get, this actually is called as assembly. The physical compilation unit of .NET program is assembly. You get it? This then goes to CLR, where there are series of operations which happen on it. So the boundary for CLR I'll draw separately. First it goes to something called as assembly oblique code loader or class loader. The job of this tool is basically to load the MSIL source code in the memory, then forward this code to the next tool called as code verifier, whose job is to check the integrity of the code. Basically, this is the tool which is responsible for verifying whether the code is not tampered with. After this code verifier gives OK, the code goes to something called as JIT compiler. And after the JIT compiler, you get the native code. So here I draw the boundary of CLR. Here the native code comes out, which is then given to the operating system for the further execution. It could happen that there is some interoperability happening with the native code written in C or C++, or some native code written in some old Microsoft environments like Plus or something, or COM or something. That code doesn't go through this cycle or this processing. The source code directly is there. I will say source native code. It gets filtered here itself and bypasses the whole CLR process and joins the native code here directly. This code which bypassed the CLR execution is unmanaged code. We discussed about this. And the code which goes through the CLR or managed by CLR is called as managed. There is one more service of CLR which comes in here for garbage collection. So not always used over here, so that's why I put it as a separate component, not in the chain. Sometimes it is used, sometimes it is not. If there is no garbage to be collected, garbage collector won't be working. So it just keeps on running as a separate thread, background worker thread, which keeps check on the memory usage, whatever variables and objects that you use, their memory usage. If the garbage collector finds that okay, this object is not in use for a long time and there is no reference of it in the program and the application is demanding more resources, the garbage collector may remove that garbage or unused object or variable from the memory. Understood? Understood? This is what we call as .NET program execution cycle or simply .NET execution cycle. or .NET execution process, regardless of the type of program, whether it is web application, console application, Windows application, or whatever the types that we have discussed. It will be always like this. Do you get it?
Yes.
Okay, now here another important term that we need to understand is JIT and assembly. So first let's talk about assembly here and then we'll talk about JIT. What is assembly? Simply the definition says physical compilation unit in .NET is what we call as assembly. When you compile your code, you get either .exe file or .dll file. By name, it looks like it is the final executable code, but that's not. It is just a file. Simply, if I create a Notepad file and while saving, I give it an extension .exe. Do you think it will be an executable file? Let's do it practically. Here I open Notepad. Here I type some text. Saving, just creating a folder structure so that it becomes easy later on for me to share the code with you, whatever we are going to write. And in that folder itself, I create this file, let's say demo.exe. Here I select all files and I click on save. Do you think it has created an exe file? Open File Explorer. Go to the location. Looking at the icon, it looks like it is an exe. Type also it shows me as application, right? Date and time confirms that this is the file we just created. Yes or no?
Yes.
Do you think this is an executable application actually? Looks like. Let's try double clicking it and see what happens. Are you able to see this? This app cannot run on your PC. The prompt it is showing me to find a version for your PC, check with the software publisher.
Yes, we are able to see.
Yes.
Why I'm getting this? Any idea? By name, it looks like it is an exe application, but operating system simply doesn't know what it is. And even if it is real executable application, how to execute? OS says, I'm sorry. Technically, it is not an exe. It is just the name which is confusing. And probably that's because with Windows, we know that .exe extension is for executable files. If you go for Mac OS, if you go for Linux, there is no extensions to the files. Correct? So who decides whether the file is exe or not? If I open this file, let's say right click with shift and say open with, let's say edit with Notepad++, it shows me behavior I see is Notepad behavior, means it's a text file. So who decides whether the file is a text file or exe or DLL or something? There is some metadata in the file, a part of which something what we call as executable header or just simply the file header. That is what decides what is the type of the file, regardless of which OS you are working with. Do you get it? Do you get it?
Yes.
And that's what is going to be important in our discussion right now. I just delete this file, close the file explorer. So, file, if I say, is represented as this big rectangle, which makes it look like a document, right? Word document. Just assume the structure of file is like this. There is a section here called as header. Okay. This is something what we call as body section or content section. Precisely. Understood? The file after compilation is .exe or .dll, correct? So here the header that will be there is called as PE header in Windows. And Windows maintains this PE header for all executable applications, exe or DLL. On Linux it may be different, on Mac it may be different, but you will still have some header. Name may be different. Windows say it is PE header. Mac OS may say XYZ header. Linux might say PQR header. Name doesn't matter. The content that is put here in this section is header. Now what PE header stands for? PE header stands for portable executable header. What this contains for a .NET exe or DLL is an instruction at the low level, something like an assembly language statement, JMP. If it is .exe, we will have core exe main. If it is DLL, it will be JMP core DLL main. Core DLL main doesn't do anything apart from loading the code. Core exe main does several things. It actually creates a process. Within the process created, it creates something called as sub-processes, which .NET terms are 3 app domains prepared by default. Now, here we first need to understand what is process. What is process? If I load operating system and all applications and my code entirely in the same memory address space, do you think it will be useful and safe? It is as good as keeping the criminals and the good people together. Kids also along with criminals and good people. What do you think? Is it a good idea? The criminals may be murderers also. Just for an example, I'm saying this. But do you think it will be a good idea? Will it be safe for all? Would anyone be comfortable staying for, say, a week with criminal people?
No.
We won't feel safe. We won't be comfortable. So if we have been given a choice whether you want to join this group or not, most likely your answer will be a big no. Am I right?
Yes.
Now, running all code together is just like that. OS running in the same address space, applications running in the same address space, then custom application softwares running in the same address space. Problem is, if one of them faces issue, maybe some exception is there, which is causing some interference in the memory, or if the error itself is because of some memory issue, the entire system will go in tizzy. And most likely it will crash. The only solution would be restart the machine. In some severe cases, even restart will not help. You have to keep it in switched off condition for around 20 to 30 minutes so that the memory residue is completely cleared. Not only shut down, you have to disconnect the power source also completely. Static electricity also you have to discharge and then restart the machine. If it is a server machine, is it acceptable for keeping the server shut down for so long? Yes or no? Tell me quickly.
No.
No.
So that is why Windows NT 4.0, in fact Windows NT 3.5 onwards, Microsoft came with a different uh, model where they say that OS will have its own isolated memory address space. Every application, whether it is genuine Microsoft application or third party application or custom application created by you, will get a separate dedicated isolated address space. Advantage with this is if one of the application is in trouble, only that process needs to be killed and restarted. It won't interfere with the other applications or the OS process. Understood? This is just like in classrooms in school or colleges. Basically, we don't have just one big hall where all classes are being held. We have different rooms for different classes. Am I right? So that there is no interference of one class into the other. What is happening in one class, it doesn't matter to the other class. Got my point? Each
Yes.
application, each operating system function runs smoothly in its own address space. So that is why we have this facility of saying Control Alt Delete Task Manager, and if we feel that one of the processes is not working fine, just select that particular process and click on End Task. I'm sure everyone must have used this task manager at least once,
Yes.
right? So that is what the process is. App domain is the same concept, but that is where the application may be depending on multiple components, and if one component fails, it should not crash the whole application. I may need the feature of the process here as well. So that's why .NET says that okay, the process can be divided in sub processes, and those sub processes are named as app domains in .NET. So it creates app domains. Three app domains are created: one for CLR, one for your application, one for the garbage collector. Understood? Then
Yes.
it loads the code. So this is where the CLR thing comes in, right? We spoke about assembly loader and classer. That tool will load the code, will get the code verified, and then hands over the execution to CLR by calling the entry point. Now, depending on type of application, there will be different entry points, correct? For console or Windows applications or Windows services, probably the entry point would be the main method. For a web application, it may not be main method. It may be application class. So depending on the type of application, whatever the applicable endpoint is, that endpoint will be called and the code will start executing. Understood?
Yes, sir.
What else we have here? Assembly will have a section called as manifest. Manifest is also called as assembly metadata. You can make a note. Manifest sometimes is also called as assembly metadata. Now what this must be? Manifest holds the information like assembly name, version, and the digital identity if provided. Some assemblies may not have digital identity. Some assemblies may have. It all depends on whether you have signed the assembly digitally or not. If signed, digital identity is there. If not signed, there is no digital identity. And this digital identity basically is very, very important when we say code verifier needs to do its job. Code verifier works if and only if the assembly has got a digital identity. Otherwise, code verifier will be skipped. So this information about the current assembly is there in manifest. Not only this information, but if this assembly depends on another assembly or another set of assemblies, the similar information about all the referred assemblies also is maintained here in manifest. Understood? Understood?
Can you please explain more about this manifest?
Okay. So if I talk about you as a person, okay, if I talk about tell me about yourself, what all things you will tell me at the very basic level. I am just interested in your identity. So what you will tell me?
Name, college, age.
Name is your full name. Maybe you will talk about your education, right? Age I may not be interested in because it's a
Residence.
professional question. Maybe skill set, specializations. Yes.
Yes.
Projects handled. Correct.
Yes.
And probably that is it. That should be enough at the very, very basic level. Maybe as a fresher, this is enough. Correct?
Yes.
This information about you is your manifest. It doesn't talk about exactly what you have learned during your education. Only high level information is there. Okay, these are the things. In fact, education is not the part of manifest. It is just the degree which is the part of the manifest. I'll say degree. Understood?
Yes.
Now relate it with the assembly. I am having an exe file or DLL file. What I need to know about it at the very basic level? These three things, no? Assembly name, version, and its identity. Unique identity. Yes or no?
Yes.
But when it comes to a proper program, this assembly may be using another assembly and one more assembly. Maybe this assembly is further using one assembly, and this assembly is depending on three separate assemblies, where this assembly further depends on two more assemblies. There can be a chain like this. Am I right?
Yes.
Now, don't you think this assembly needs to know about this and this assembly?
Yes, it is required.
Which, what is the identity of this assembly? So assembly name, version, and identity. All three things about this assembly must be recorded somewhere here, and same with this also. Correct?
Hmm. Yes.
This assembly now, if I talk about, has got another dependency. So don't you think this assembly should know about this one?
Yes.
Similarly, this assembly should know about this one, and this one.
Yes.
And then further, this assembly should be aware of this one and this one. Correct?
Yes.
And apart from this, each of these assemblies must know about themselves. Who am I? Right?
Yes.
That's what manifest is.
Okay, so
Understood?
basically we are storing the details
Correct.
of the linked assemblies.
Correct.
Thank you.
And why it is important? What do you think? Because this is how the assembly loader and code loader will come to know what I am supposed to load. But my point,
Yeah.
we don't have a Windows registry database used over here, right? So we are not
Yes.
recording this information anywhere. So in that case, this information must be recorded within the component itself, correct?
Yes.
So when I load this component, it knows that what I am supposed to be aware of further, correct?
Yes.
So that's manifest. And what is the other name I used for manifest? What it is called as?
Assembly metadata.
Assembly metadata. Then there is next section called as metadata. This metadata section is also called as type metadata. I said type metadata. Okay. Now when I say type metadata, first of all we need to understand what represents type. Type in .NET can be a class, struct, an interface, an enum, or a delegate. Some of them may have their members, like class, struct, interface, and enum have members. Like class struct may have variables, I mean fields, properties, methods, and then subclasses and like that. So for now I'm keeping this only. Interface probably will have only properties and methods. Yeah, one more thing I'll put here, events. So interface may have events as well. Enum will just have the basic members, name members. So nothing to mention here as such. Delegate, again we'll just have a reference of some function. I'll not put it. Okay, now when I say fields, fields will have data type, name, position, where they are located in sequence. Same goes with properties. Same, almost same thing applicable to methods, right? Method will have name, method will have a return type, method will have parameters. Now when I say parameters, parameters also will have data type, name and position. Whether it's a first parameter, second parameter, third parameter and so on. Right? What all this is? In general, when I say what is metadata, what we say? Data about data, correct?
Yes.
So what we are looking to understand here? We're talking about metadata and then we came to this and then this. Don't you think this metadata is actually data about the types and their members? Detailed information. Yes or no? How many classes I have, how many structs I have, how many interfaces I have, how many enums I have, how many delegates I have, and then based on the answers, what are the members of these entities, what are their names, what are their data types, what are their positions, whatever is applicable. This all information goes in metadata of the assembly. Understood? Do you think this all information is required to be recorded somewhere? I'll
Yes.
make it simple for you guys. If I give you a DLL and I tell you whatever the functionality is there in this DLL, you write a program to use that whole functionality. And there is no document share. There is no verbal communication about what this assembly contains, the DLL contains. What are the members of that assembly? I don't tell you anything. Would you be able to write the program?
No.
What minimum information you need? Probably the same information we just discussed. Yes or no? What are the members? What are their types, etc. Yes or no?
Yes.
That's why probably somewhere it needs to be documented. And don't you think it would be nice if the component stores that documentation within itself? Even if I don't have a separate document, I can still work with it. Your answer becomes yes if it is a .NET code, .NET assembly. Even if I don't tell you anything, don't share any document, you can still identify what this component is, what are the members of it, and what all inputs they take, what all output they give. You can still write the code. If it is a non-.NET component, then it's a challenge. You will not be able to do anything without documentation. Understood? There is a tool that .NET Framework provides you, IL Disassembler. IL Disassembler. This tool basically allows you to load the assembly and see what it contains. So even if I have not shared any documentation or any information with you about my DLL, with the help of this tool, you can just go through what all things are there and you can write your program easily without wasting time. Do you get it? Yes.
Yes, sir.
So,
This is the reason why these assemblies are also called as self-describing components or self-describing assemblies. Mainly self-describing components. They talk about themselves. They carry their catalog. Isn't it nice? The next section is where they contain the IL code. And then there is an optional section where we have something called as resources. What are resources? Not variables or objects. These resources are something to do with the translation dictionaries. The programs which you write these days are multi-language programs, right? But you write just one copy, let's say, which is based on US English. So your all menus, the button titles, label titles, all will be displayed as US English, right? If you want to make it multi-language application, probably you will create a dictionary. Let's say you want a French version as well. So you'll create a French dictionary within which you will have all US English words and their French versions mentioned as key value pairs. Correct? So wherever the US English word is used, once I apply French language to my application in settings, automatically the French version of the word will be used. So my user interface will show all menus, button text, label text, or whatever text wherever getting rendered as French. Understood? So this dictionary basically is put into resources if available. It may not have only the text, it may have images, it may have audio, video files also, because the images also needs to be sometimes specific to, especially if that image is having some text within it, or if I'm using video or audio, the spoken language and that has to be changed as well. So I'll have different versions, right? So based on the language selected, the version of that video or audio should be played, or the version of the image should be rendered. All this information goes in the resource dictionaries. Understood?
yes.
That was all about the assembly. Now let's talk about the JIT compilers. How many JIT compilers we discussed are there?
3.
Three. Can you name?
Just in time, pre-JIT,
No,
and
that is standard. Then Econo,
Econos person.
and then we have pre-JIT. Right?
Yes.
Now to understand what they are and what is their difference, we'll have some pseudocode. Assume that this is actually some .NET code. So I have a main function. It's got 3 lines of code. Apart from this main, I have function A, function B, and function C. C has got couple of lines of code. B has got couple of lines of code. A has got couple of lines of code with call to B next, 1 line of code further, and then finished. Here in main, after 3 lines of code, call to A is there. couple of lines of code, then call directly going to B, then a single line of code, and then one more call to A is there, couple of lines of code further, and finish. What that code is, don't get into that. Just understand the structure. I give you 2 minutes, just analyze the flow. Then we will go further and understand what standard JIT is, how it works to process this code. So, shall we proceed? Yes?
Yes, sir.
Let's consider standard JIT first, how it works. When I say just in time, what does it mean? When required, then compile. So, when I compile the source code using language compiler, what do I get? Suppose C# was used, I'll get IL code, right? Now, IL will go through the just-in-time compilation. Yes or no? The default just-in-time compiler is standard JIT. So let's say this comes into picture. There is no machine code generated yet. What happens here is simply the machine code once created has to be loaded back in memory somewhere for execution. So maybe you might have gone through the memory segmentation where we talk about that memory is divided in two parts, in fact 4 parts: stack, heap, code segment, and data segment. Where stack and heap are for holding our data, data segment is for holding the static information or static data, and code segment is basically for holding the code, executable code. Correct? If not aware of this, just make a note of this and just do little bit of research how the memory is divided. That should be your question to Google, and you will get plenty of information about this segmentation. Understand? Now, our code cache is the term used by .NET environment for the code segment. Okay. So what happens when I start running this application? When I say I start running the application, what does it mean? Now it is the time to compile to the machine code. Yes or no? Tell me quickly. Yes or no? Now, without final machine code
Code cache,
available,
sorry, excuse me, code cache is the term used by .NET environment.
.NET for code segment of the
Okay.
memory. Okay. So what I was talking about is now I need to start the program and I'm using standard JIT. So can I run the program without having its machine code in code segment or code cache? No, because machine understands only machine code, correct? Yes or
Yes.
no?
Yes.
So what standard JIT will do is will not compile the whole code together. It will just compile main. Whatever code is there in main, even call to A, will be recorded as an instruction only. So the entire code in main is compiled to machine code and put into code cache and starts executing. So 1, 2, 3. These are normal regular statements, expressions, they are processed. Then the fourth one is basically a call to function A. It again checks whether I do have the compiled code for A in code cache or not. So if you look at this, what will be the answer? Do I have the code for function A into code cache? Yes or no?
Yes.
No, code cache has got code only for main. A doesn't exist here. So it compiles the code for A and converts it to machine code and loads it here. Understood? And then because there is a call to A, it starts executing here. 1, 2, normal statements. Then there is a call to function B. What happens? When there is a call, it again checks the code cache. Do I have the code for function B in code cache?
No.
Not yet. So what it does?
It will call.
Compiles, converts to machine code and loads it here. And then starts executing function B. Only two statements, it returns back over here. Function B is retained. It's not removed just because execution is finished. For future usage. Comes here, processes this statement. From here it returns where it started. Again, A is not deleted, A is retained for future use. Executes next two statements which are plain statements. Then the next statement is called to B. Same question. Whenever there is a call, the question is, do I have that function code in code cache? This time I get the positive answer, right? I do have the code for function B in code cache. Yes or no?
Yes.
So what will happen this time? Will the compilation take place once again or directly execution will start?
Directly execution.
1, 2, the statements execute, return, comes here, executes this. Call to A, same question. I have function A already here. So it jumps here, 1, 2, 3. Call to B, it's already there in code cache. So these two statements and then fourth statement here. Return, process this and finish. When I finish the main, that is the time when all the code in the code cache is removed, deleted. Because I'm done with the program, right? So I should clean up the memory. Yes or no?
Yes.
At the very end, all the code is removed. Otherwise, it just gets retained. Multiple calls to the same function will not result in multiple time compilation. Compilation for each code item is done only once. Is it clear? Is it clear?
Yes.
This is
Yes.
for which type of compiler?
Standard
Standard JIT.
just time. Yeah.
Standard JIT compiler. Correct? Now let's understand how the EconoJIT works. Econo stands for economical. So this becomes the default compiler if the program is running on the kiosk or the mobile device or the tab, I mean small scale devices with limited resources. Understood?
Yes.
And why economical version is needed there? Because we have limited resources. Processor may not be that powerful. RAM amount might not be that much, correct? We may have just 1 GB of RAM or 512 MB of RAM, 2 GB of RAM. We don't need to look at the high-end models over there. The thing is, what is the device configuration that is used by the majority? So in countries like India, probably 80 to 90% population uses the average configuration devices only. Am I right?
What are the average configuration devices?
I would say something around 4 GB of RAM.
Okay.
That's a standard, right? Many of us may have the phones which has got just 4 GB of RAM. It will increase in days to come as the prices come down for 8 GB RAM based models, but as of now the standard is 4 GB. We might be using 8 GB ones also, but then there is majority crowd which is still using 2 GB or 1 GB also. So average comes down to 4 GB only, no? Am I right?
Yes.
Okay. So don't you think the way how the coding or the code is actually compiled, the strategy has to be different here? Of course, yes. Now let's consider EconoJet, how it works. Initially the processing is same. There will be nothing in code cache. So assume code cache is empty. Okay. This is the section you have to refer. It's empty. I say run this program. It compiles main and loads it into code cache. Starts executing. 1, 2, 3. Call to A. There is no function A code available here. So A is compiled. Added to code cache. Starts executing. 1, 2, 3. It's a call to B. There is no B function over here. So compile B and start executing. So 1, 2 and return. Now till here you might say that what is the difference? It is the same. Yes or no?
Yes, it's same only.
Till here, yes, it's same. But the moment I return from here, being EconoJet being used, the thing is, once the scope of B is finished, the code for function B is deleted from the code cache. It returns to A, completes A. A returns. Again, here the code for function A is removed. So what is remaining in code cache now? Only the code for main. Correct?
Main only. Yes.
It comes back here, executes the next 2 lines of code. Then there is a call to B. Do we have function B loaded in code cache? No, this time, because it's already deleted. So again it will compile B and load it in code cache. Start executing this. 1, 2, return. The moment it returns, the B function is again deleted. Execute this line of code. Main is still running, that's why main is retained here. Main is not finished, right? Then next is call to function A. Again, function A doesn't exist here. So function A is compiled. 1, 2, 3. 3 is called to B. B is not there. B is compiled and loaded here. And then executed. 1, 2. Return. The moment I return, this is deleted. Function A completes and returns. So code for function A again gets deleted. It returns back here, completes the next 2 statements, and now the main is also deleted. So the compilation of each function is going to happen on the basis of how many times they are called. Do you get it?
Yes.
Whereas in case of standard jet, what was happening? Each function is getting compiled only once when it was called first time. One thing to be noticed in both these cases, the function C has not been touched at all. There, not a single time code cache had the code compiled for C, right?
Yes.
Reason?
Because it is not in the main.
Not being called anywhere. Can I say that?
Yeah.
In the chain.
Yes.
So C is not at all there. So even if my program is very big and complex, the footprint, the memory footprint of my application will be depending entirely on what all features I'm using, correct?
Yes.
Isn't it highly optimized in both the cases?
Optimized in both.
Yes. Now let's see prejet. Prejet is not like this. For prejet, I have to actually compile the code before it executes. So I deploy the code on the target machine, and on that, suppose the file name is xyz.exe. What I have to do is I have to use the .NET tool called as ngen.exe, and the parameter I pass to this file as xyz.exe. Right? What it does, it creates a new xyz.exe and overwrites this one. But the difference will be this is going to be your IL code based xyz.exe. Here now you will get native xyz.exe. If you copy this exe on another machine which has got a different processor architecture or different OS, this exe will not work because it's native. Now, in this case, the exe, the physical file itself contains the compiled, final compiled native code for the entire program, whether it is being used or not. So that file will have main, that file will have A, B, and C also. Everything compiled, and when the code loader, assembly loader, class loader works, the code cache will also have a copy of main, A, B, and C all loaded, preloaded, the moment you start the application. So in this case, when I say start application, main directly is taken from code cache and starts executing 1, 2, 3. Fourth is called to A. A already exists in code cache, so directly start executing 1, 2, 3. 3 is called to B. B is already there here. Start executing B here. Come back here, return, execute these two statements, call to B, it's already there, so again execute B, and then return here, execute this, call to A, so second time execution of A, call to B, this is third time execution of B, return, and then return here. So there is no actual compilation happening when the program is running. Before the program is run, you get your IL code converted to native in the physical file, and that native code directly gets loaded in code cache whenever you say I want to run this program. That is why it is called as pre-just in time. Understood?
Yes.
Now tell me with this, in which situation, I mean for which type of applications you will use which type of compiler. Suppose my program is a mobile application. Which jet compiler I will use?
Econo.
Reason?
Lower configuration.
Lower configuration. I cannot keep all the code always loaded, right?
Yes.
I may run out of memory resources if I do so, correct?
Yes.
So it's easy. Now, suppose there is a banking application or let's say healthcare application, uh, part of which basically is being used, a module is being used for patient registration at the help desk. That's the first thing, right? We go to hospital and we go to the help desk and we get registered there. Some forms needs to be filled up and they do the computer entries. Yes or no?
Yes.
Yes.
Okay. Overall hospital would be a automated software based hospital only. Even if some scans are happening, some lab tests are happening, all information will go to the system only. Correct?
Yeah.
Okay. But say the operator on help desk is just doing patient registration. So one module being used. The lab guy will probably access that patient ID and will upload the reports against that patient ID. Correct? Against a prescription. The doctor will just access the patient ID and create prescriptions. Prescriptions may be for tests, prescriptions may be for medicines, right?
Yes.
Okay. In such cases, for the client side interface, suppose it's a desktop application, which compiler is going to be used? Econo is ruled out. So you have got two choices only, standard or pre.
Pre-JIT.
Why do you think so?
Because the basic details are already loaded, so it can be
No,
used.
no. In this case, I'm using only a piece of code. If I'm a doctor, I'm just handling one module. If I'm a front desk operator, I'm operating only one module. If I'm a lab test guy, I'm operating only one module. There may be hundreds of modules. But at any point in time, I may not be using more than 2 to 3 modules. Why should I get the code for the entire program which has got hundreds of modules loaded in memory? Do you think it is optimized use? Don't think about data, it's only about the modules, the code. Data anyways will not be loaded in memory, it will be coming from database only. Correct?
Yes.
So what do you think?
Stand.
Isn't standard JIT better here?
Yes.
Only the code for the module that I am working with or I'm using gets compiled and loaded in memory, not the entire program. Make sense or not?
Yes.
Understand?
So where we will be using pre-JIT?
Where we will be using pre-JIT, right? Now suppose this is a client server application. All complex processing, data analytics, report preparation is happening in the backend. There is a server for it with very heavy configuration. Usually that's what happens, right? X-ray reports came. Okay, the data has been fed. Then let's say CT scan, MRI reports are there, whose data has been fed to the system. Doctor will not be looking for the raw data. They want analysis so that there is less burden on them. Maybe if I'm using a software, the software should suggest the treatment directly based on the inputs received by the different tests, right? And then doctor just adds on to it. They verify whether the treatment suggested by the software is correct or not, and then accordingly they suggest the patient. So even if there is no senior doctor available on a particular day for that particular patient, a junior doctor can also handle the patient with this. Yes or no?
Yes.
Now, in this case, don't you think anyone can ask for anything? Because it's a server, right? Lab test guy
Yes.
will also be connecting. The front desk operator will also be connecting. Doctor will also be connecting. The uh, medical store will also be connecting. And at times, patients also will be connecting. Yes or no?
Yes.
We cannot predict which module will be asked by whom at what time. Correct? Anytime, any request may come. Am I right? So I have to be ready with everything. One simple example here. During elections, on the election day itself, when you go to the vote, uh, I mean voting center, there, first of all, you need to find out where, in which uh, polling room you are supposed to go. And how do you find that? Mostly there is a list of voter IDs against which the room number is mentioned, right? So you go there and you check for your name in the list or your voter ID in the list. Am I right? Am I right? So that you come to know in which room you are supposed to go. There may be 3, 4 rooms, 5 rooms, depending on the load on that center. Correct?
Yes.
This is as good as like when you go for your board exams, 10th or 12th. You don't know which room you are basically supposed to sit in, right? So where do you check? You check for your roll number. Against roll number, you have a room number. Correct?
Yes.
So don't you think the school in this case or the voting center has to maintain a list which is having the information about everything, every single candidate who is coming to vote or who is coming to give the exam?
Yes.
Anyone can come at any time, especially when it is voting, right? Voting starts at 7 a.m. and ends at 5 p.m. So anyone can come at any time. So we have to keep
But
everything
for one,
ready.
but for one particular area, we don't need to have the list of all the can.
Agreed. But for that specific area, there may be thousands of people coming in, no?
Yes.
So let's focus on that part first.
Okay.
Right. So suppose there is a server which is surveying 100 hospitals. I am talking about one such hospital. So don't you think whatever module for that hospital has been created, each module needs to be in ready condition? Just like relay race, the member of each team needs to be in ready to run condition. Anyone can come first and the second person has to run the further race. Correct?
Yes.
It's like that. So that is where the prejet is going to be used. So mostly this prejet is used for server side applications, and these two are used for client side applications. And when to use standard, when to use econo, I'm sorry, that is already answered. Econo is for smaller devices, right? Standard is otherwise used. Is that clear?
Yes.
Pretty smart, right? We have been provided with an option so that we get most optimized implementation. Yes or no?
Yeah.
Okay, this is not able to show it properly. Let me show you the website. This is some good to have kind of information. The overall evolution of .NET, how and when which version came. .NET 1.0 was officially released on 13th Feb 2002. 1 year later, .NET 1.1 was released on 3rd April 2003. .NET 2 was released on January 22, 2006. It was planned to be released in November 2005 only, but got delayed for some reasons and finally got released on Jan 22, 2006. Then these all were full-fledged releases. When .NET 3.0 came, it was not a full-fledged release. .NET 3.0 was a add-on framework on existing .NET 2.0. So it basically came in with 4 different subset frameworks for .NET in addition to what .NET 2 was providing. Those frameworks were WPF, Windows Presentation Foundation, WCF, that is Windows Communication Foundation, WF, that is Workflow Foundation, and then there was something called as card space for maintaining the profiles, user profiles, or maybe preferences. Understood? And then another major release, full-fledged release came in year 2007, November 19. That was .NET 3.5. Then came .NET 4 in April 12, on April 12, 2010, 3 years later. 2 years down the line, and on August 15, 2012, we got .NET 4.5, and there were some service packs released for it, which eventually got named as .NET Framework 4.5.1 and 4.5.2. Their release dates mentioned. October 17, 2013, we got .NET 4.5.1, and May 5, 2014, we got .NET 4.5.2. Then next major release was .NET 4.6, which was on 20th July 2015. Again, just like .NET 5, 4.5, we got some service packs to this with minor improvements, bug fixes and all, some basic additions. So their release dates are 30th November 2015, we got first revision, and 2nd August 2016, we got second release, second revision for .NET 4.6, which was further enhanced with a major release with .NET 4.7. The release date was 2nd May 2017, and again it also had two service packs or two revisions, October 17, 2017 and August 30, 2018. And then came .NET 4.8 on 18th April 2019, which is the latest release till date, and Microsoft has no plans to come up with another version over here for .NET Framework. They'll keep supporting the .NET Framework 4.5, 4.6, 4.7 and 4.8 for a long time, but there will be no more new versions of .NET Framework. So what would happen to .NET after this? In year 2014, they came up with the completely open source version of .NET, which was named as .NET Core. So .NET Core version 1, 1.1, .NET Core version 2, 2.1, .NET Core version 3, 3.1 came in, and then they said that there will be no two different branches of .NET like .NET Framework and .NET Core, as people were getting confused. They decided to merge both of them into finally open source thing only. So after .NET Core 3.1, they came with .NET 5, followed by .NET 6. Simply, that is .NET Core implementation only, but they wanted this version to be enhanced as well. So .NET 5 onwards, we don't have two types of .NET frameworks. We have just one. That is open source and cross-platform version. It's no more called as .NET Core or .NET Framework. It is just called as .NET. Understood? Understood?
Yes.
Okay, so that is all about the .NET platform, the .NET framework, and related things. It's almost the time for lunch break. We'll go for the break. Once we come back, we will then be starting with C# language fundamentals. Okay? So it will be more practical thing now. Fine?
Yes.
Okay then. So see you again at 2 p.m.